Okay, so for the 30th day, it's called distress signal, and we are finally receiving some messages on our handheld device on the radio from the elves. But the problem is that it's still broken, so we receive some packets out of order. And the question is, for the first question, how many packets are in the right order? So basically a packet is just a nested list of numbers, and to figure out if a packet should be first or not, we have to compare the numbers and see which has the smallest number first, basically. So the packets arrive on the device in pairs of 2, and we have to compare each pair and see if it's in order or not, if the packets in that pair are in order or not. So to compare them, there are basically 3 cases. So first, if we have 2 integers, the lower integer should come first, and if the first packet has the lower integer, then it's in the right order, otherwise it's not. Then if both values are lists, we have to compare each item from the list, and if we find an item that is smaller, then it means that that packet should be first. And if we go through all the numbers in that list and we figure out that all the numbers are equal with each other, the packet with the shorter list should come first. And the last case is when we have to compare an integer with a list. So in this case, we have to convert the single integer into a list with only one element and compare the lists as before. So you can imagine that we will have to do this probably recursively until we find a packet that is smaller than the other. So at the end, we will receive all the indices of the packets that were in the right order, and we have to sum these indices. But you have to be careful because the counting starts from 1 for this packet, so the first packet should have the index 1 and so on. For the second part, we have to discard all the white spaces and just consider all the packets in that we received so far, and we have to add 2 divided packets, one with 2 and one with a 6 in it. Then we have to sort all the packets and get the index of the 2 dividers, and then multiply the 2 dividers, and that should be the decoder key for the distress signal, and also the puzzle answer for the second question. So for the solution, I created an enum called packet data that will represent a nested list. So to parse this packet data, I created a helper function called from stir helper, I guess, for the packet. And yeah, here I guess in Python it would have been so much easier, just a call to eval and that's it. But in Rust, I'm not sure if there is a better way, but I did it character by character. So basically, if we find an opening bracket, then we have to recursively parse each item in that list. And yeah, if it's just a number, then we will parse it as a number, but if it's again another list, we'll go recursively once more until we find the closing bracket for that list. So yeah, I mean, it's pretty disgusting, the code for parsing the nested list, but it does the job, so whatever. Then I thought it would be helpful to implement the compare trait for the packet. So what I did was to implement this compare function that receives the self packet and another packet, and we have 4 cases. First, when this packet is a single value and the other packet is a single value, so we can just compare the 2 values as integers. The other case is when this packet is a value but the other one is a list, so what we can do is to convert this value into an array, into a vec, and compare it to the other vec. So we just recursively compare the 2 packets as lists. The next case is that the self packet is a list and the other packet is an element, so we convert the other packet to a list, and again, as before, we just compare the 2 packets as lists. And the last case, which was I guess more interesting, was that both packets were lists. So what we had to do was to iterate through the zipped version of the two vectors, and if one item was different from the other in this pair, then we would just return the comparison between them, because that's a point where the 2 items are different, so we are sure that one of the packets will be smaller than the other. But if we go through all the items in the 2 vectors, then it means that they were both equal So we have to compare the length of each vector, and the one with the smaller length will be smaller. Also, I think that to be able to implement already, you have to implement EQ. So I did the exact same thing for EQ, but instead of using compare, I used EQ. And that was pretty much all that we need to do for the packet data. Then I had a simple packet struct with the left hand side and the right hand side, just to not use tuples, I guess. And to implement from string for this structure, we just get two lines, and the first line we parse using packet data, and the second line we parse it the same way using packet data and return the resulting packet. To parse the input, we split everything but by double new lines and map the results into packets. For the first part, we want to get all the packets that are in order, so we have to compare the left hand side packet with the right hand side packet, and if they are if the left hand side is smaller than the right hand side, then it means that the order is correct. So we keep the index of that packet, and at the end we sum all the indices up. And yeah, as I said, you have to make sure that you start from 1 or at least add 1 at some point to these indices. Then for the second part, we just have to convert all the packets into a single vec. So I just flat mapped over all the packets and collected everything into a vec of packet data. Then I added these two delimiter packets. Then I sorted the packets, and I just searched for the 2 and 6 delimiters and got their indices and multiplied them together. So yeah, this was the 13th day. It was okay. It was simpler than the other days, but yeah, it was to be expected because usually the harder days are on the weekend. So yeah, and as always, if you want to look at the source code, you can find it on GitHub, and see you next time.